Hi everyone. In today's lecture, I will discuss the LPC214X microcontroller, which is a very popular ARM7 based microcontroller family used in embedded system applications. Instead of memorizing features, we will understand why LPC214X is important, how its internal blocks work together, how it supports real-time embedded application. Let us begin by understanding what makes LPC214X special in ARM-based series microcontrollers. First, we'll discuss on why LPC214X. LPC214X belongs to NXP's ARM7T DMIS based microcontrollers. The main reason this microcontroller is widely used is it combines high processing power which with rich peripherals in a single chip at a low power. This makes it ideal for embedded control systems, industrial automations, IoT gateways, and communication based projects. At the heart of the LPC214X is the ARM70 DMIS core, which supports both 32-bit ARM mode and 16-bit thumb mode with a frequency of 60 MHz. And also it has flash memory, SRAM, on-chip peripherals, SIDS, everything. Next, we will discuss with the internal architecture as a picture view. If you look at LPC214X internally, it can be divided into four main sections: ARM7 processor core, memory system, peripheral subsystem, system control, and power management. All these are connected using high-speed internal buses, mainly AHB for high-speed communication, APB for peripheral access. This separation improves performance and reduces power consumptions. Next, we'll discuss ARM7 core, the simple explanation. The ARM7 core is a RISC processor, meaning instructions are simple, execution is fast, move and instructions complete in one cycle. It uses pipelining mechanisms. The pipelining mechanisms fetch, decode and executes. Because of pipelining, while one instruction is executing, the next instruction is already being prepared. This increases throughput without increasing the clock speed. ARM7 also supports low power operation, which is very important for embedded devices. In the next, this diagram shows the pipelining execution. It has register banks, multiply registers, barrel shifters, instruction decode, fetch, decode, execute, and write back. Everything is present in this ARM Core 7 architecture, which enhances the pipelining execution as the effective one. Next, we'll discuss on memory organization in a practical way. LPC416, LPC214X is a have many memory devices. It is mainly divided into two types of memory, that is flash memory. It is used to store program code, non-volatile. It retains data even after power off. SRAM based memories used for variables, stack and runtime data, which is faster than flash memory and it is volatile. To improve the performance, LPC 214X uses memory accelerator model. This allows the instruction to be fetched in a faster manner. It reduces the wait states and better execution speed. So even though flash is slower, the memory accelerator model makes execution almost as fast as SRAMs. The next pin configurations. So the pin configuration of the LPC214X is shown in this diagram. It has around 64 pin chip with many features. One important features of LPC 214X is multifunction pins. A simple pin can act as GPIO, UART, SPI, ADC input and external interrupts. Which function the pin performs is controlled using pin cell registers. This gives design flexibility, reduces pin count, compact PCB design. Fast GPIO supports allows high speed digital operations. The GPIO generally stands for General purpose input and output, UART, universal asynchronous receiver and transmitter, SPI and ADC inputs. The next one is timer and PWM and communication. LPC214X includes two 32-bit timers used for delays, counting and event measurements. PWM unit useful for motor speed control and LED brightness. For communication, it supports UART for serial communication, SPA and SSP for high-speed data transfer, I2C for sensor and device interfacing. These peripherals makes LPC214X suitable for real-time control and communication-based systems. The next one is UART, SPI, SSP, I2 interfaces. UART has two types, that is UART 0 and UART 1 for asynchronous communications, SPI and SSP for synchronous communication, I2C and 0 and 1 for fast mode as well as sensors and device interfacings. It has two modes, master mode as well as slave modes. The next one is ADC and DAC, USB and power manage power modes. The LPC214X also includes 10-bit ADC for analog signal inputs. Yet the 10-bit ADC for analog outputs use full speed controller useful for PC connectivity. Power management is another strength which is takes in ideal mode and power down mode. These modes helps reduce power consumption when the system is not fully active. The USB. The USB is full speed USB device controller with endpoint RAM. The ISP and IAP supports for booting and flash programming. The clock and power modes. We have on-chip oscillators and PLL for CPU clocks, which makes the processing speeds, ideal and power down modes. The ideal and power down modes helps in reducing power consumption when the system is not fully active. Power control and wake up resources, we have RTC, real time clock, BOD and interrupts for maintaining the powers as well as as a wake up resources. As a conclusion, we have say LPC214X is a powerful yet flexible microcontroller that combines ARM processing, RISC peripherals, efficient memory system, and low power operation. That is why it is widely used in embedded system design. Thank you for your patience.